In the vast tapestry of the universe, there is a riddle that refuses to unravel, one so enigmatic that it challenges everything we think we know about reality itself. Imagine a substance that neither shines nor casts a shadow, a cosmic presence that makes up nearly 85% of all matter, yet remains completely invisible to our most advanced instruments. This is not a plot from a science fiction novel, but a profound puzzle that has gripped scientists and dreamers alike for nearly a century. They call it dark matter. Looking up at the night sky, we see galaxies swirling, stars blazing, and nebulae glowing with vivid color. But the visible universe, the dazzling light show, is just the surface. Beneath this brilliant veneer lies something profoundly elusive, a hidden architecture of matter that neither emits nor absorbs light in any form we can detect. How do we know it exists? We see its fingerprints everywhere, tugging silently on galaxies, bending light across vast cosmic distances, shaping the very scaffold on which the universe is built. Yet it refuses to be caught. Think of a spider weaving its web in the dark, the strands unseen, but the vibrations unmistakable. Dark matter is much like that web, invisible, intangible, yet essential. Without it, galaxies would tear themselves apart, the cosmic dance would lose its rhythm, and the universe as we observe it might look very different, or perhaps not exist at all. The mystery deepens when we consider how it interacts with the ordinary matter, the atoms that make up stars, planets, and everything we hold dear. It does not collide like billiard balls, nor form molecules, nor dance in the electromagnetic embrace. Instead, it passes through us by the trillions every second without a trace, making the very act of detecting it feel like chasing a ghost through an endless forest. Intriguingly, clues have emerged not only from observing distant galaxies but also from subtle discrepancies in the motion of stars within our own Milky Way, and peculiar flickers in the cosmic microwave background, the afterglow of the Big Bang. Each of these signals hints at the vast, unseen ocean of dark matter, yet they also raise profound questions. What is its nature? Could it be some unknown particle? A whisper from another dimension? Or something even more exotic that defies current scientific paradigms? What does this mean for us, standing on a small blue dot amidst the cosmic expanse? If the universe we see is only a fraction of what truly exists, how does that reshape our place within it? The search for dark matter is more than a scientific quest, it is a voyage into the unknown, touching on fundamental truths about existence, invisibility, and the limits of human understanding. Tonight, as you look out into the starry abyss, remember that the universe is not just a spectacle of light but also a silent enigma. Somewhere beyond the shimmer, an unseen presence holds sway, an ancient secret concealed in the shadows, waiting, perhaps, for us to finally glimpse its essence. In the chapters to come, we will unravel this cosmic mystery, tracing the faint whispers of dark matter through space and time, and exploring how this hidden force challenges everything we thought possible. In the vast expanse of the cosmos, the laws that govern light and matter have guided our exploration for centuries, celestial bodies moving in elegant orbits, light bending under gravity's pull, the dance of energy and particles painting the universe's story. Yet, lurking beneath the fabric of this cosmic dance lies a component that defies our senses and instruments, a silent architect of structure and motion that neither glows nor shadows, but whose gravitational whispers shape everything we see. To begin unraveling the enigma, we must first understand the fundamental framework upon which modern cosmology rests. At the heart of this lies Einstein's theory of general relativity, which reimagines gravity not as a force but as the curvature of spacetime itself. It suggests that massive objects warp the fabric around them, guiding the paths of stars and photons alike. Scientists have used these principles to predict the behavior of galaxies, galaxy clusters, and the universe's grand expansion with remarkable success. Yet, when these predictions meet observations, a puzzle emerges: galaxies spin too fast at their edges, light bends with greater intensity, and cosmic structures form in ways that ordinary matter alone cannot fully explain. These anomalies point to a hidden mass, dark matter, that exerts a gravitational force yet remains invisible to every other form of detection. But what if this unseen mass is not a uniform sea but something woven into the universe's very architecture? Some researchers propose that dark matter may be connected to the properties of space itself, an exotic form of matter whose behavior differs vastly from anything familiar. Unlike the atoms in our bodies or the plasma of stars, this matter would not interact electromagnetically, it would not absorb, emit, or reflect light. It might be more like a cosmic scaffolding, underpinning the visible universe. Curiously, the echoes of this hidden substance whisper through the cosmic web, the vast, filamentary network of galaxies and galaxy clusters extending across billions of light-years. Current models suggest that dark matter forms the backbone of this web, guiding ordinary matter into the complex patterns we observe today. Without it, simulations cannot replicate the richness of the cosmic tapestry, nor explain the incredible density of galaxies clustered in some regions while vast voids lie in others. Yet, the nature of dark matter remains elusive, prompting scientists to study it from every conceivable angle. Experiments beneath the Earth's surface, shielded from cosmic rays and electromagnetic noise, strive to capture the faintest interactions, subtle hints that would reveal dark matter's particle identity. The candidates range from weakly interacting massive particles known as WIMPs to ultralight axions and even more speculative exotic particles born from the early universe. As each new model emerges, scientists refine their understanding, navigating between the realms of possibility and constraint. Another fascinating dimension arises from observations of gravitational lensing, the bending of light around massive objects. This phenomenon spotlights the invisible mass congregating in galaxy clusters, shaping the path of photons lighting their way to us. In some cases, the distribution of dark matter seems to diverge from where ordinary matter clumps, suggesting that dark matter may have its own independent journey through cosmic history, unbound by the electromagnetic forces that govern atoms and molecules. Beyond galaxies, the very formation of the first cosmic structures, stars, galaxies, and clusters, depends intricately on the influence of dark matter. Without this hidden mass, the universe's visible structures would have taken far longer to coalesce, or perhaps never formed as they did. It acts as a gravitational catalyst, seeding regions where gas can collect and ignite the fires of star birth. It is a silent collaborator in the creation of cosmic complexity, quietly shaping the evolution of everything that shines in the night sky. As investigations continue, a deeper philosophical question surfaces: is dark matter a substance at all, or a manifestation of yet-to-be-understood physical laws? Some theories speculate that what we term dark matter might hint at modifications to gravity itself, a subtle reshaping of reality on cosmic scales. Though these ideas remain in the realm of speculation, they underscore a humbling truth that our current scientific tools might only be scratching the surface of a richer, stranger universe. In peering into this cosmic abyss, we confront not just a scientific challenge but a profound sense of wonder. Dark matter embodies the mystery of invisibility on the grandest scale, a reminder that much of reality eludes direct observation, residing instead in the interplay of effects and shadows. It calls us to expand our imagination and rethink our place in the cosmos, standing at the threshold of knowledge where science meets the unknown. In the journey ahead, we will explore how this unseen force shapes the universe, from the smallest scales of particle physics to the grand cosmic structures spanning millions of light-years. But for now, we pause to acknowledge the delicate balance between certainty and mystery, that in the cosmic symphony, some notes remain unheard, their melody carried not by light, but by the invisible hand of dark matter. In the quest to understand dark matter, scientists have ventured beyond the familiar landscapes of visible galaxies and swirling nebulae, diving deep into a realm where light fades and the invisible reigns supreme. The principal framework that guides this exploration is known as the cold dark matter hypothesis, a model that has shaped modern cosmology yet leaves us with more questions than answers. At its core, this theory suggests that dark matter is made up of particles unlike anything found in the known zoo of atoms, photons, or neutrinos. These elusive particles do not emit, absorb, or scatter light, which is why they lie forever hidden from conventional telescopes. Instead, they interact feebly with ordinary matter, revealing themselves only through their gravitational influence on stars, galaxies, and the vast cosmic web that threads the universe together. Imagine a vast, invisible scaffold sprawling beneath the stars, a framework on which galaxies hang like ornaments swaying on a cosmic tree. This scaffold, a hypothesized dark matter halo enveloping galaxies, acts as the gravitational glue holding them together against the centrifugal force of their rotation. Without this unseen mass, galaxies would not hold their shape, they would tear themselves apart as the outer stars spun away into the void. But the story becomes even stranger when we consider the behavior of these halos. Current models indicate that these dark matter structures are not smooth or uniform. Instead, they clump into smaller halos, substructures that serve as cradles for galaxy formation. This hierarchical nature, reminiscent of fractals, hints at a universe where complexity blooms from simplicity through the invisible hands of dark matter. The scientific pursuit to identify the exact nature of these particles has given rise to a fascinating variety of candidates. Among them are weakly interacting massive particles, or WIMPs, hypothetical particles that might have formed in the hot early universe and survived until today. These WIMPs, if they exist, could occasionally interact with normal matter in subtle ways so faint that detecting them requires enormous underground laboratories shielded from cosmic rays and earthly radiation. The slow, persistent search for these ghostly encounters continues to inspire hope among researchers, a testament to human ingenuity and perseverance. Another intriguing possibility is that dark matter is made of axions, ultralight particles proposed decades ago to solve other puzzles in particle physics. Unlike WIMPs, axions would be so abundant and diffuse that they might behave more like waves than particles, creating a cosmic background field that subtly influences the universe's evolution. Detecting axions demands novel experimental approaches, pushing the boundaries of technology and imagination alike. Yet, despite the mounting world of theories and experiments, none has yet delivered definitive proof. The silence from the dark matter frontier prompts some scientists to contemplate more radical ideas. Could it be, for instance, that dark matter is not a particle at all? Some theoretical constructs propose that new forces or symmetries, hidden from our current instruments, weave through the fabric of the cosmos. These hidden sectors, if they exist, might interact with normal matter only through gravity or other faint channels, making their discovery an extraordinary challenge. One of the greatest mysteries lies in the early moments of the universe. According to the prevailing cosmological model, information encoded in the cosmic microwave background, the afterglow of the Big Bang, carries subtle fingerprints of dark matter's presence. Tiny fluctuations in this ancient light reveal a dance between normal matter and its shadowy counterpart, shaping the density waves that would later grow into galaxy clusters and superclusters. The patterns observed hint at properties dark matter must have, but do not specify its identity. Furthermore, the large-scale cosmic web, the vast network of galaxies and voids stretching across billions of light-years, seems to align exquisitely with simulations that incorporate cold dark matter. This consistency strengthens the model's credibility, but also deepens the enigma. Whatever dark matter is, it must behave in ways that allow such intricate structure to form and persist over cosmic time. The implications stretch beyond mere astrophysics. If dark matter particles were detected and characterized, they would unravel threads connecting cosmology, particle physics, and perhaps the ultimate laws governing the universe. They could help answer profound questions: what is the nature of mass? Could there be entire hidden sectors of reality, parallel in complexity but invisible to us? Could dark matter itself hold clues about the fate of the cosmos, influencing its expansion and, possibly, its end? As we ponder these questions, it becomes clear that dark matter serves as a cosmic mirror, reflecting human curiosity and the limits of our understanding. It challenges the very framework through which we interpret the universe, urging a humility that is rare in scientific endeavor, a reminder that the universe, in all its grandeur, remains more mysterious than we can imagine. Thus, the main theory of dark matter is not just about a missing mass, but about an invitation to look beyond what is seen, to seek what is hidden, and to embrace the uncertainty that fuels discovery. It is a narrative woven through the fabric of the cosmos, composed not only of equations and experiments but of wonder and the undying quest for knowledge. In this unfolding story, each new observation and experiment becomes a turning page, waiting to reveal whether dark matter is indeed a particle, a field, or a deeper principle of nature. Until then, it continues to whisper across the void, a silent enigma urging us to listen more closely with every passing generation. Beneath the vast expanse of stars and galaxies lies a profound silence, a silence defined not by absence, but by the overwhelming presence of something unseen. Dark matter does not shine or scatter light, it evades every direct method of detection we have devised. Yet, its gravitational fingerprint is unmistakable, etched subtly into the cosmic landscape. This invisible substance, woven into the very architecture of the universe, grows increasingly pivotal as we expand our scientific understanding beyond traditional frontiers. Consider, for a moment, the concept of cosmic scaffolding. Current models indicate that dark matter forms an immense web throughout space, a skeletal framework upon which galaxies cluster and coalesce. Without this scaffold, the cosmic canvas would be eerily barren. Galaxies might never have emerged in the swirling, majestic shapes we observe today. This invisible web, composed largely of dark matter, may be guiding the grand ballet of matter and energy across billions of years and unimaginable distances. Intriguingly, this leads scientists to explore implications far beyond gravity's silent pull. If dark matter interacts even faintly with ordinary matter or with itself through unknown forces, it might subtly shape the physics of the early universe in ways we have not yet grasped. Imagining these interactions opens doors to questions that stretch the fabric of physical law itself. Could these elusive interactions help explain why the universe appears finely balanced? Might they influence three-dimensional space, or even hint at hidden dimensions beyond our perception? Expanding further, some researchers speculate that dark matter may influence the behavior of black holes, those enigmatic regions where gravity reigns supreme. Could dark matter form halos around black holes, altering their growth or the emission of gravitational waves when they collide? With gravitational wave astronomy entering an era of precision, subtle shifts in these cosmic ripples might harbor clues to dark matter's nature, granting us indirect glimpses into its elusive character. Astronomers have also probed large-scale cosmic phenomena to infer dark matter's role in shaping the universe's evolution. Observations of galaxy clusters reveal a curious disparity. Visible matter accounts for only a fraction of the total inferred mass. This discrepancy hints at yet again an unseen influence, complicating how these colossal structures form and behave over cosmic time. These clusters act as natural laboratories, anchoring our understanding of how dark matter could sculpt the universe's skeleton and, potentially, its future. Even more mysterious are hints that dark matter might not be entirely dark in the electromagnetic sense. Certain models propose that it could emit or absorb faint signals outside the spectrum we traditionally examine, in ways so subtle they skirt the boundaries of detectability. Imagine a shadow that briefly flickers at wavelengths yet unexplored, signals that current instruments might miss, but future observatories could catch. This possibility introduces a tantalizing tension between what we perceive and what might lie just beyond the horizon of our instruments. This subtlety challenges one of the fundamental assumptions we hold about the universe, that its invisible components are completely inert. Instead, they might harbor dynamic properties, perhaps evolving over billions of years. If this is true, dark matter could be a shapeshifter, transitioning between states or even interacting with forms of energy we have not yet discovered, affecting cosmic expansion or the birth and death of stars in ways still far beyond our understanding. The speculative frontier reaches even further. Some contemporary models delve into the idea that dark matter might be a harbinger of new physics altogether, a gateway to phenomena beyond the standard model of particle physics. If dark matter is composed of particles unlike anything we have observed, understanding their properties could force a radical rethinking of the fundamental forces that govern reality. It might reveal hidden symmetries or break existing paradigms, akin to the revolutions instigated by relativity and quantum mechanics a century ago. Moreover, uncovering the essence of dark matter could have pragmatic implications. One day, if harnessed or understood, it might illuminate new technologies or energy sources inspired by phenomena currently deemed purely theoretical. This adds a dimension of human curiosity that echoes through history, humanity's relentless pursuit to transform mysteries of nature into tools of progress, a narrative as old as science itself. Yet, within the scientific possibilities lies a more profound mystery. Dark matter represents a boundary between the known and the unknown, demanding a different kind of thinking. It tempts us with the promise of answers but insists on patience, urging caution lest we impose certainty too soon. Each experimental result, each astronomical survey, continually reshapes our grasp of its nature, sometimes raising more questions than it settles. As our instruments become ever more sensitive, and as new observatories come online, probing from deep underground labs to satellites surveying the farthest reaches of the cosmos, the legacy of dark matter grows richer and more intricate. It is a reminder that science is not a fixed body of knowledge but a dynamic journey, where each mystery invites a deeper exploration. Perhaps, in the end, dark matter is less a missing piece and more a profound signal, an invitation to broaden our vision, to question deeper assumptions about the universe's workings. It asks us to imagine a cosmos that is more intricate, more hidden, and more alive in its complexity than any prior generation dared conceive. In the interplay of observation, theory, and speculation, dark matter stands as a symbol, both a challenge and a beacon. It stretches the limits of human imagination and scientific ingenuity. The story of dark matter is far from complete, and its mysteries beckon us onward, to listen more attentively, to question more boldly, and to explore more deeply the beautiful dark beyond the light. As we pause to contemplate dark matter, not merely as a scientific puzzle but as a profound existential enigma, we find ourselves at an intersection where cosmology converges with consciousness, where questions about the universe ripple into questions about ourselves. What does it mean, fundamentally, to inhabit a universe whose vast majority is composed of something invisible, elusive, and beyond direct perception? This unsettling reality forces us to re-examine deeply rooted notions about existence and the fabric of reality itself. In human history, darkness has often symbolized the unknown, a realm of hidden truths, fears, and potential revelations. Yet, dark matter transforms this metaphor into a literal puzzle embedded in the cosmos, challenging us to rethink what real truly means. If more than 80% of matter eludes direct detection, the solidity of our everyday experience feels suddenly fragile, an illusion reliant on shadows and indirect signs. Philosophers have long pondered the nature of reality. What can we trust to be real if so much goes unseen? Dark matter compels us to consider that what lies beyond our senses, and even the most advanced instruments, may constitute the true backbone of existence. Moreover, it's intriguing to reflect on how this invisible majority quietly orchestrates the cosmic dance, galaxies forming, stars swirling, clusters assembling, with a gravitas that dictates the structure and evolution of the universe. In a way, dark matter acts like an unseen composer, its presence shaping the symphony of cosmic history without ever playing a note audible to us. This analogy invites a poetic perspective. Perhaps reality is composed not only of what we can see or measure but also of hidden forces and layers that defy direct interaction, hinting at dimensions of existence we have yet to fathom. Could dark matter be a whisper from the deeper architecture of reality? A message encrypted in the fabric of spacetime that beckons humanity toward new modes of understanding? From a consciousness standpoint, there emerges a profound parallel. Just as dark matter governs the large-scale structure of galaxies beyond the reach of our current senses, there are realms of human awareness and understanding that remain shadowy and uncharted. The mind grapples with its own invisible elements, subconscious drives, intuitions, and ineffable experiences that escape neat explanation. Dark matter's mystery mirrors this inner frontier, reminding us that the universe is not only an external enigma but also invites an inward journey into humility, openness, and wonder. This intersection between cosmic mysteries and the nature of consciousness opens a door to interdisciplinary reflection. Some thinkers speculate, cautiously and without asserting certainty, that the dark cosmos might influence or resonate with the evolution of consciousness itself. If the majority of matter is dark, could it be that consciousness, or perhaps aspects of existence beyond physicality, are entangled with these unseen realities? While such notions remain speculative and far from scientific consensus, they underscore the profound humility dark matter imposes on our understanding, not just about stars or particles, but about the essence of being. In the grand material and metaphysical tapestry, dark matter stands as a symbol of paradox and possibility. It is a reminder that the universe is not a simple ledger of visible objects and straightforward laws but a deep mystery layered with subtlety and nuance. It invites us to question the very frame through which we interpret nature, the assumption that what we can observe directly is all there is. According to some interpretations of modern physics, including those inspired by relativity and quantum mechanics, reality might be woven from more than just particles and fields. Perhaps the universe's most basic fabric includes hidden dimensions, energies, or processes that we perceive only as faint gravitational effects or distortions of spacetime. In this light, dark matter can be seen not as an anomaly to be forced into pre-existing paradigms, but as a challenge to expand the boundaries of science and philosophy alike. The mystery lies not solely in what dark matter is, but in what it compels us to reconsider: the nature of observation, the limits of knowledge, and even the place of consciousness within the cosmos. It sparks an invitation to embrace uncertainty, to celebrate the unknown as fertile ground for new ideas, and to nurture a sense of cosmic humility amid the vast unknown. In the quiet shadows where dark matter dwells, we hear a call, an echo from the depths of existence urging us to reimagine the cosmos not as a static tableau of known facts, but as a living, unfolding story threaded with mystery. It asks us to become explorers not just of the stars, but of meaning itself, to venture beyond the comfort of certainty into a vast unknown where science and philosophy merge, where new perceptions of reality await discovery. And in this pursuit, perhaps the greatest revelation is not what dark matter is, but how it transforms us, the observers, by expanding our capacity for wonder, curiosity, and profound reflection upon our place in the cosmic night. Imagine for a moment that the universe is less a grand, neatly organized puzzle, and more a vast, shadowy wilderness, dark matter acting as an invisible forest that shapes the landscape without ever revealing itself to our senses. This unseen realm, countless times more abundant than the stars and galaxies we know, quietly holds the cosmos in its grasp, yet remains completely elusive. While we have mapped the familiar contours of visible matter, the blazing lights of stars, the swirling arms of galaxies, there is this pervasive presence, a spectral companion influencing every cosmic dance in ways we've barely begun to fathom. As researchers peer deeper into the universe, they encounter phenomena that suggest dark matter's presence might be even stranger than previously imagined. Some speculate it could consist of exotic particles that slip through our detectors like whispers, or unimaginably vast structures weaving through intergalactic space, threading unseen connective tissue between galaxy clusters. But beyond particle hunts, there are even more unsettling possibilities, challenges to the very foundations of physics and our understanding of reality. Consider the possibility that dark matter is not simply matter at all. What if it's a reflection of a hidden property of space itself? Instead of being composed of particles, it may be a manifestation of geometry regions where space bends, stretches, or folds in ways that evade direct detection. According to some speculative interpretations, dark matter's gravitational pull might arise because spacetime harbors unseen defects, distortions that curve the universe's fabric subtly but persistently. This suggests our universe is more like a vast, multidimensional origami, and what we call dark matter is a shadow cast by unseen folds. If so, our instruments, sensitive as they are, may only ever glimpse the effect, never the origin. More provocatively, certain ideas propose that dark matter might be a kind of cosmic memory or record, a ghostly imprint left by events in the far past, perhaps echoes of primordial processes during the universe's fiery birth. In this frame, dark matter is not an active substance, but a lingering signature encoded in the cosmos's structure, a residual trace of profound transformations from an epoch when space, time, and matter were forged. In this way, the universe might be telling a story, one written not in starlight or particles, but in the invisible script of dark matter's subtle influence. Adding to this mystery is the paradox that dark matter could be connected to yet uncharted dimensions of reality, realms that lie outside our observable universe or beyond the reach of current physics. According to some interpretations, dark matter may be part of a shadow universe, a parallel domain that touches our own only through gravity's delicate threads. This idea invites a haunting image of interwoven realities, layered like translucent veils, imperceptible but present, influencing us from the shadows. Our universe, then, could be just one verse within a larger, hidden cosmic symphony. If such possibilities hold even partial truth, the implications ripple far beyond astrophysics. Dark matter might challenge our understanding of causality, space, and the nature of existence itself. It may hint that the universe is fundamentally more complex and stranger than any previous era of scientific inquiry has acknowledged. The enigma pushes us to a profound philosophical brink. What does it mean to know the universe if significant aspects remain forever beyond direct observation? Is the cosmos inherently mysterious, or is our blindness a temporary barrier awaiting new instruments, new minds? In the search for dark matter, scientists engage with these unsettling questions not just as intellectual exercises, but as an emotional journey. There's a certain quiet awe in confronting what cannot be seen, a humbling reminder of how small our terrestrial vantage point is within the vast unknown. This shadow realm, though silent and unseen, stirs a deep curiosity, a whisper of possibility that fuels the human quest for understanding. Each new anomaly, each unexpected observation nudges us toward new paths of inquiry, and into territories where science blends with wonder. Thus, the mystery of dark matter is not a single riddle to be solved, but a multifaceted challenge that shakes the foundations of our knowledge while inspiring transcendent reflection. It is an invitation to look beyond the familiar map of the cosmos and to embrace a frontier defined by absence yet filled with presence, a presence that shapes galaxies, underpins realities, and beckons us onward. Dark matter may forever remain hidden, yet its shadow guides us to question, to explore, and to dream about dimensions of existence that stretch beyond light and matter. In the heart of this mystery lies a paradox. The most abundant substance in the universe is the one we understand least. And in that paradox, there is a strange beauty, an open door not only to new science, but to a deeper, more profound connection with the cosmos itself, where embracing the unknown becomes a path toward cosmic insight. The journey into the dark matter wilderness continues, and with each step, the universe invites us to reconsider what is possible, what is real, and what remains forever just beyond our grasp. As we draw the curtain on this voyage into the enigmatic realm of dark matter, we find ourselves not at an end, but a threshold, standing on the edge of a vast cosmic question whose answers remain elusive yet ever compelling. The story of dark matter is, in many ways, a narrative about the limits of perception, the artistry of inference, and the audacious human drive to illuminate the unseen. In contemplating this unseen scaffold of the universe, we confront a profound paradox, that much of what shapes our reality lies beyond the reach of direct observation, challenging us to expand not only our instruments but also our very imagination. Consider the subtle gravitational tug on celestial bodies that betray the presence of something unseen. These delicate distortions in spacetime act like cosmic fingerprints, hinting at a hidden architecture holding galaxies in graceful motion. Yet, as profound as these clues are, they only sketch a shadowy outline of a larger and more intricate truth. Scientists believe that dark matter weaves through the universe like an invisible web, anchoring the cosmic tapestry, but what it truly is remains a question wrapped in layers of mystery. Current models suggest that the dark matter puzzle may intertwine with physics beyond the familiar, a whisper from realms not yet charted by particle accelerators, or perhaps an echo of phenomena that defy our classical frameworks. Could it be that we stand on the precipice of discovering a new kind of matter, one whose properties challenge the very assumptions that have guided physics for a century? Or is dark matter an emergent phenomenon, a collective effect born from the interplay of forces yet to be fully grasped? These possibilities invite a humility of thought, reminding us that the universe's complexity often outstrips our most elegant equations. Beyond the scientific intrigue, dark matter carries profound implications for how we perceive our place in the cosmos. If the matter we know, the atoms that construct stars, planets, and life itself, compose barely a fraction of the universe's mass-energy budget, then what does it mean for our understanding of existence? It suggests that the narrative of the cosmos is far richer and stranger than the story written in the starlight visible to our eyes. The vast majority of the universe may operate under principles and dynamics utterly foreign to our daily experience. In this reflection lies a poetic resonance and echo of philosophical wonder that has accompanied humanity since we first gazed upward. Dark matter challenges the notion that knowledge is merely the accumulation of facts. Instead, it embodies the evolving nature of understanding, where questions often eclipse answers, and where the unknown invites a perpetual dance between skepticism and curiosity. It reminds us that science is not a closed book but an open dialogue with the mystery of existence. Visualize the cosmos not just as a collection of shining orbs suspended in space, but as a grand symphony orchestrated by unseen forces. Dark matter, then, might be the elusive melody, one that, though inaudible to human ears, shapes the cadence and flow of the universe's unfolding story. Through this lens, our quest transforms into more than scientific pursuit. It becomes a profound encounter with the unknown, an invitation to wonder at the hidden harmonies that sustain reality. As our instruments and theories grow sharper, so too does our awareness of how much remains veiled. Yet, this is not cause for disillusionment but a call to embrace mystery as an essential part of the scientific journey. The search for dark matter, with all its uncertainties, stands as a testament to human ingenuity and the enduring spirit of exploration. In the quiet spaces between what is known and what lies beyond, the story of dark matter pulses, a silent ode to the universe's unfolding enigma. And perhaps the greatest revelation today is this: in seeking to unveil the universe's invisible threads, we may come to understand more about the nature of mystery itself as a horizon that simultaneously eludes and beckons, a horizon that defines the very frontier of human knowledge. As the cosmic voyage continues, dark matter remains one of the most compelling invitations we have ever received to look deeper, question further, and embrace the vastness not only of outer space but of possibility itself. It is a reminder that the universe does not surrender its secrets easily, but in its reticence, it gives us the most profound journey of discovery, one that transcends matter, light, and form, reaching into the heart of what it means to know, to seek, and ultimately, to wonder. To grasp the true scale of dark matter's presence, imagine standing at the shore of an ocean so vast that the water you see, the glittering surface of stars, gas, and dust, is barely a skim of what lies beneath. Beneath this familiar ocean of luminous matter, the majority is hidden, invisible, yet it shapes the tides of an entire cosmic realm. Current scientific models suggest that about 85% of the matter that clumps the universe together is this elusive substance we call dark matter. But what if we could think beyond the usual celestial mechanics and imagine dark matter as a kind of cosmic scaffolding? Like the hidden framework of a colossal cathedral, dark matter provides the architecture upon which galaxies are built, the invisible lattice holding the universe's sprawling structures in delicate balance. This analogy invites us to visualize galactic clusters as grand cathedrals built from bricks and mortar shaped by visible matter. Yet, the mortar itself, the unseen glue, could be dark matter, exerting gravitational influence from behind the curtains, silently pulling galaxies into place, guiding their dance through the vast darkness. The way these clusters behave, their cohesion and motion, whisper hints at a force that neither emits nor absorbs light, refusing to be seen through conventional telescopes. Turning to a less cosmic but no less enlightening analogy, scientists draw parallels with a familiar phenomenon much closer to home: the way sound waves behave in fog. Fog obscures the light and visual details but does not erase the sound. In a similar vein, dark matter doesn't shine or reflect, it is like a fog of influence in the cosmic landscape, discerned only through its gravitational signature. Just as fog muffles but shapes sound differently depending on its density and distribution, dark matter's fog warps the paths of light and motion of visible matter in subtle, measurable ways. One particularly intriguing observation arises from peculiar galactic rotations, where stars at galaxies' edges don't behave as classic physics predicts. According to Newtonian dynamics, these peripheral stars should drift into the void, thrown away by insufficient gravitational pull. Yet their velocities remain unexpectedly high, suggesting something unseen holds them in orbit. The theory suggests an unseen mass, not emitting or absorbing light, is providing this gravitational glue. This phenomenon hooks astronomers into what some call the galactic mystery, a riddle not just about what dark matter is, but how it shaped the very emergence of structures in the universe. Beyond individual galaxies, the cosmic web, the immense network of filaments formed by galaxy clusters and voids, also provides a canvas upon which dark matter's influence paints an invisible but intricate pattern. According to current cosmological simulations, this web owes much of its shape and extent to the dynamics of dark matter. The gravitational pull of this mysterious substance predicted the filamentary structure we observe today, lacing the cosmos with threads of matter spanning hundreds of millions of light-years, drawing ordinary matter along with it. But perhaps the most fascinating aspect to consider is how dark matter challenges our notions of what constitutes reality itself. What if, hidden within this invisible material, lurk new forms of particles unlike any ordinary matter, operating under laws yet to be discovered? Some theoreticians speculate about particles that interact so weakly with the known forces, they pass through us, through every atom, without a whisper. If such particles exist, their presence calls into question the completeness of the standard model of particle physics, urging a profound revision of our understanding of matter's fundamental nature. Additionally, the possible interplay between dark matter and dark energy, the two shadowy components dominating the cosmic budget, propels us into a speculative realm where gravity itself might differ subtly from Einstein's picture on the largest scales. The idea suggests that perhaps what we perceive as invisible mass is an emergent phenomenon arising from a yet undiscovered gravitational behavior or exotic physics. This alternative approach, though speculative, emphasizes how mysterious and deep the puzzle remains, pushing the boundaries of known science. From a more philosophical perspective, the persistent enigma of dark matter invites us to reconsider the essence of visibility in the cosmos. Is what we see with our eyes or instruments the full truth? Or is reality perpetually just beyond our grasp, shaped as much by absence as by presence? Dark matter illuminates this tension, standing as a profound silence amid the cosmic symphony, a force without voice that nonetheless commands the grand orchestration of galaxies and clusters. In the search for dark matter, humanity's instruments have grown more sensitive and sophisticated, from underground detectors designed to catch the faintest particle interactions, to massive telescopes tracking gravitational lensing that bends light around unseen masses. Yet each new advance reveals new layers of mystery rather than final answers, like peeling a cosmic onion whose core remains tantalizingly out of reach. Such ongoing discovery reminds us that science is a living process, where every explanation invites new questions, and every shadow deepens the mystery. Ultimately, understanding dark matter is not merely about cataloging an unknown substance or explaining cosmic anomalies. It may reshape our comprehension of existence itself, offering clues about the hidden forces sculpting reality. Whether dark matter turns out to be a new particle, a modification of gravity, or something even more exotic and unexpected, its discovery would echo across multiple fields, from cosmology to particle physics, from philosophy to the very way we think about the cosmos. As the instruments reach deeper into the darkness, as simulations grow more intricate and as observations become ever more precise, dark matter remains an enigma, a silent rhythm beating beneath the luminous universe. It is a mystery not just of physics but of imagination, a question that refuses closure, reminding us that the pursuit of knowledge is a journey not simply towards answers, but towards richer, deeper wonder. In this unknown, the cosmos invites us to rethink the very nature of reality, blurring the lines between the light we know and the shadows we seek to understand. If dark matter is a hidden thread woven through the cosmic tapestry, then perhaps it also challenges the fabric of time itself, an invisible undercurrent that shapes not only where galaxies move, but when and how events unfold in the grand symphony of the universe. Time, as we perceive it, flows forward, steady and unwavering. Yet, current models of cosmology suggest that the cosmos is far from uniform. Regions dominated by dark matter might subtly influence the flow of temporal experience on scales we are only beginning to glimpse. Could the presence of unseen mass distort not just space but the cadence of time itself? This possibility nudges us toward questions that border philosophy, inviting reflections on the nature of reality beyond the measurable. Consider consciousness, often regarded as the intimate, insubstantial core of human experience. What if our awareness, our sense of now, is somehow linked to the unseen scaffold of matter and energy, a construct that extends beyond ordinary detection? Some speculative ideas propose that the deep structures underlying space, time, and matter might influence how consciousness emerges or functions. While these notions sit firmly outside established science, they offer a poignant metaphor. Even our inner worlds may be shadows cast by a cosmic architecture still hidden in darkness. The implication stretches further. If dark matter composes the majority of the universe's mass-energy balance, what does this mean for human significance? Our senses and instruments reveal only a fraction of what exists, suggesting that the universe's dominant reality is not the glowing stars or planets, but something invisible, eerily quiet, and profoundly mysterious. In this context, humanity's search to unveil dark matter is not just a scientific quest, but an existential one. It forces us to reconsider our place in the cosmos, not as central actors commanding the stage, but as observers navigating a deeper, more complex backdrop. This invisible presence, quietly shaping the cosmos, reminds us how much remains beyond perception and how humility is essential in the face of the unknown. The search for dark matter also mirrors our own experience with uncertainty and the limits of knowledge. We live in a world comfortable with the visible and the measurable, where science aims to illuminate every corner. Yet, the universe beckons us toward embracing ambiguity, an invitation to live with questions that may resist definitive closure. The darkness we seek to understand may be less about a cosmic puzzle to solve and more about a state of being to accept, the coexistence of light and shadow, knowledge and mystery, certainty and wonder. In this silence where dark matter dwells, there lies an echo of something fundamentally important. Not only does it serve as a reminder of humanity's reach beyond the known, but it also reflects a deeper narrative about existence itself. Here is a story where invisible forces shape matter, time, and perhaps even thought, where what is unseen commands just as much influence as what we can detect. As we push the boundaries of technology and theory, we are learning that reality might not be a simple stage set in light, but a vast theater where darkness holds equal, if not greater, sway. Thus, in contemplating dark matter, we peer into more than a scientific unknown, we gaze into the nature of being, of presence, of the silent rhythms that underlie the cosmos and, possibly, ourselves. This realization humbles and expands us, reminding that the ultimate mystery is not only what dark matter is, but how it quietly shapes the universe and our place in its unfolding story. As we deepen our journey into the enigmatic presence known as dark matter, we encounter a realm where familiar intuition begins to falter. Unlike the tangible substances we can weigh or observe, dark matter eludes every traditional attempt at direct detection. It does not emit, absorb, or reflect light, standing as a silent architect behind the grand cosmic structures we see. Scientists believe that this enigmatic ingredient adds up to about 85% of the matter in the universe, yet it remains invisible to all the tools crafted for ordinary matter. Consider an analogy from the world of sound. Imagine entering a room filled with countless musical instruments, yet all are silent. However, you feel vibrations subtly shaping the air, guiding the rhythm of the story being told within the space. Just as these inaudible forces influence the environment, dark matter operates as an unseen yet gravitationally potent presence that lends structure and coherence to the cosmic orchestra. One particularly remarkable example of dark matter's influence lies in the behavior of galaxy clusters, the universe's largest gravitationally bound systems. Clusters are cosmic cities where thousands of galaxies live and interact, their movements dictated by gravitational tugs. Current observational models indicate that galaxies within these clusters move too swiftly to be held together by the visible matter alone. This discrepancy has led scientists to infer that a vast, unseen reservoir of mass, dark matter, exerts a gravitational grip that keeps these galaxies in orbit. Without it, the clusters would rip themselves apart, an unsettling thought that hints at the precarious balance sustained by the invisible. In recent years, another extraordinary phenomenon has offered indirect clues about dark matter's presence: gravitational lensing. According to Einstein's theory of relativity, mass bends the fabric of spacetime, and light traveling near massive objects follows curved paths. By studying subtle distortions in the images of distant galaxies, astronomers can map out the unseen mass responsible for these gravitational effects. The patterns revealed often don't align with the distribution of visible matter, offering a tantalizing glimpse into the hidden scaffolding of the universe built upon dark matter's invisible framework. Yet, despite these profound insights, the physical nature of dark matter still escapes our grasp. Various candidates have been proposed by theoretical physicists, ranging from weakly interacting massive particles, WIMPs, fictional inhabitants of quantum realms, to axions, hypothetical particles that could weave the universe's fabric with undiscovered fields. An intriguing new angle lies not only in imagining what dark matter might be but in pondering how its elusive behavior challenges the foundations of physics itself. Could it be that our understanding of gravity needs extension or revision when dealing with these vast cosmic scales? Some scientists wonder whether modified gravitational laws might better explain the observations usually attributed to dark matter, although current models have yet to fully reconcile these ideas with experimental data. Beyond the realms of galaxies and clusters, dark matter could influence the formation and evolution of the smallest astrophysical objects. Some simulations posit that dark matter may have seeded the earliest stages of star formation or even contributed to the unexpected distribution of matter in certain cosmic voids, immense expanses that appear almost devoid of galaxies. If true, this would imply an intimate and ongoing interaction between the mysterious dark sector and the visible cosmos, a relationship far more intricate than a mere gravitational backdrop. Moreover, the implications of dark matter stretch beyond astrophysics into the subtle questions about the universe's ultimate fate. The way dark matter clumps and interacts, however faintly, might steer the cosmic expansion, the slowing or accelerating of which influences whether the universe spreads into nothingness or contracts in a dramatic finale. While dark energy has dominated these discussions, dark matter's silent hand remains a vital piece of the puzzle, entwining with forces yet fully understood. On a profoundly human level, the study of dark matter reflects our ceaseless endeavor to glimpse what lies beyond ordinary perception, to map the contours of the unseen terrain that houses our cosmic story. It invites us to embrace a complementary vision of reality, where absence bears as much intrinsic value as presence, or what is not seen shapes the destiny of everything that is. In the coming decades, cutting-edge experiments seek to push past the current frontiers, from underground detectors buried deep within Earth's crust, designed to catch rare and fleeting interactions, to ambitious space telescopes aimed at probing gravitational whispers across the void. Each new finding holds the promise of revealing further layers of the cosmic veil, transforming mystery into knowledge, and perhaps reframing our place within the vast mystery we call existence. For now, dark matter remains both a scientific enigma and an enduring muse, a shadow that beckons us forward with the quiet promise of discovery. It is a testament, above all, to the universe's profound generosity, granting us glimpses of its deepest secrets if only we dare to look beyond the light. In contemplating the enigma of dark matter, we are inevitably drawn into a deeper meditation on the nature of reality itself, an intricate weave not solely composed of what we can measure or touch, but of what quietly shapes existence from the shadows of our understanding. If the universe's visible matter is like a candle's flame, bright and immediate, then dark matter may be likened to the unseen air around it, supporting, influencing, yet forever elusive, refracting our very conception of time, space, and consciousness. Current scientific thought suggests that the universe operates on scales and in dimensions far beyond human intuition, where the familiar rules of cause and effect blur, and the concept of time unravels in unexpected ways. Some physicists hypothesize that dark matter might exist in dimensions hidden from our ordinary senses, a layer of reality that intersects with ours, yet remains imperceptible, a silent companion entwined with the fabric of spacetime. This idea challenges us to rethink what it means to exist, nudging us toward a vision where the known universe is merely a sliver of a much grander, multi-dimensional continuum. The mystery of dark matter may also reverberate profoundly within the realm of consciousness. When we perceive the universe, we engage in a delicate dance between observation and interpretation, informed by our neural architecture and shaped by our sensory limitations. Could it be that dark matter, in its intangible presence, also symbolizes the parts of our inner experience, those unconscious currents and hidden depths that shape our thoughts, memories, and aspirations? Just as dark matter holds galaxies together, so too might the unseen layers of our psyche grant coherence to the complex tapestry of human experience. Moreover, reflecting on dark matter invites us to revisit the philosophical idea of presence and absence, a dialectic stretching back through millennia. The void, often feared as an emptiness, may hold creative potential, a silent force from which new forms and structures emerge. Dark matter, as a conceptual presence made of absence, offers a cosmic metaphor for this paradox. It gestures toward a universe where the invisible scaffolds the visible, where silence carries meaning, and where the absence of direct detection is not failure, but a profound kind of presence. When we consider time itself under the lens of dark matter, current models hint at a fluidity, one where time might not be a linear river flowing steadily forward, but a dynamic field influenced by hidden matter and energy. If dark matter affects the rate at which the universe expands and contracts, it also plays a role, however indirect, in the unfolding narrative of past, present, and future. This notion challenges the human inclination to see time as fixed, reminding us instead that our experience of it is provisional, a ripple on an underlying sea of cosmic uncertainty. At the heart of these reflections lies a universal longing to find meaning amid the inscrutable. Dark matter, while a scientific puzzle, also serves as an emblem of our quest to understand the unknown. It symbolizes the boundary between knowledge and mystery, urging us to embrace uncertainty not as a void to be filled hastily, but as a fertile ground for awe and wonder. It teaches humility, reminding us that the cosmos is not fully deciphered nor controlled, but an open question inviting curiosity and reverence. As we peer deeper into the darkness that pervades almost everything we cannot see, we are met with a profound invitation to hold space for that which defies comprehension, to value shadows as much as light, and to nurture a patience befitting the cosmic scale on which these mysteries unfold. Dark matter may never reveal itself fully, or perhaps it will do so in ways that transcend our current scientific paradigms. Either outcome carries a message. Our understanding of the universe is a living story, one that grows not by answers alone, but by the questions that move us toward the horizon of the unknown. In this sense, dark matter is not just a scientific enigma, but a mirror reflecting the deeply human aspects of our existence. It embodies the tension between knowing and wondering, between visibility and invisibility, between certainty and possibility. Its presence or profound absence nudges us toward a kind of philosophical grace, the ability to accept that some truths lie shrouded in shadow, inviting us to contemplate a cosmos that is as much about what remains hidden as what is revealed. To engage with dark matter, then, is to embark on a journey beyond mere scientific inquiry. It is to step into a liminal space where the boundaries between physics and metaphysics blur, where the pursuit of knowledge intertwines with the search for meaning. In that space, we glimpse not only the foundations of the universe but the contours of our own consciousness, fragile, curious, and forever reaching into the dark.